Hi there. My topic was new product development. What I wanted to explore in this topic was how I could extract information from feedback that we receive from user on a product. So I played with the dataset from Amazon product feedback, where there is a bunch of feedback from Android apps. The dataset is about 300 megabytes in size. I am using Kafka, Spark, NLTK, and sklearn to extract some information from this dataset. So concretely speaking, my scenario is to be able to train on the feedback that we receive in an offline process. And then whenever we get new feedback from a user, we could directly score that feedback to see which topic it belongs to. The tools that I'm using are Anaconda. This is to manage my Python environment. Kafka, which is really a distributed, partition, and replicated comic log streaming platform. Spark, that helps doing analytic for large-scale data processing. NLTK, which is a library making it easy to do natural language processing and analysis, and scikit-learn, which is a data mining and data analysis tool, who also have some interesting data mining and analysis capability. So the dataset I'm using, as I just mentioned, is the product datasets. I'm only taking a subset of it, otherwise it's multiple gigs, and it's composed of all this field. For this prototype in particular, I'm just using the review text, which is the feedback entered by the user. For the installation, there is really nothing too hard. I'm using, again, Conda to manage my Python environment. I'm installing Kafka and creating a topic in Kafka. Then I'm using Spark to do some aggregation on my dataset, and NLTK and scikit-learn can just be pip installed into the Python environment. So here are some configuration steps to install Kafka, to start Zookeeper, starting Kafka as well, and then creating the topic. Overall, the architecture is as follow. So we have a client application, and from this client application is where, in theory, the feedback will be coming. The feedback will be going directly to our Kafka queue, but one can imagine that we will also have a parallel call to a relational database just for persistence. So this Kafka queue will then push to a Spark app. So we'll have a daily job that is going to read everything that is on the Kafka queue, do some data cleansing, text analytic, aggregation, visualization, and training multiple models. The best model will be then stored, and we can use this best model to score new incoming feedback near real time. So one can imagine that during the day, I'm receiving a bunch of feedback, I'm trying to extract the topic that they belong to, and then during the night, I can retrain on my whole data set and see if the feedback that we receive actually did belong to that feedback. So we can do some retraining. Now I'm jumping into some code highlights. So of course, I'm using Python for all of the project. One of the things here that I'm doing is just I'm reading through my JSON file, and then for each entry on my JSON file, I'm taking just the review text part of it, and then I'm sending it to my Kafka queue. Another extract of my code is to subscribe to Kafka. So I have my Kafka consumer object, I subscribe to my topic, and then while I'm getting messages, I process that message. So the process that I'm applying is doing text tokenization. I'm also filtering out the unique token, so the unique words that happen, that exist. I'm counting the number of unique words. I'm tokenizing the sentence. Then I'm counting the average word per sentences. I'm doing bigrams and trigram. And then finally, all of this is going to be pushed into a Spark data frame. And there I'm just counting the average number of words and the standard deviation for all of our words together. build the model, as I mentioned, I'm using scikit-learn. So I'm just fitting my vectorized data into my transform pipeline, and that creates the LDA trained model. I'm also I found a good example that shows how to do it for non-negative matrix factorization and for latent semantic indexing model. This piece of code is just for the LDA model. I'm going through each topic and I'm just showing the 10 biggest words that belong to this topic that are composing this topic. And that code highlight is showing how we could calculate similarities. So if I have a sentences, a new feedback that I'm receiving, I want to see how similar it is with different topic that I already extracted previously. So let me show you some of the result and visualization that we have. So here are all the topics that were created from my previous training. I'm also doing a visualization of the words, distance, and the cluster between these words. So you can see there are some cluster proximity of all of these words. And I'm also showing how we can do topic exploration using LDA Vs. So let me jump into my virtual machine now. And so that's the Jupyter notebook that I'm using. So that's my producer script. So as I mentioned earlier, I'm going to my JSON file and I'm extracting each line and I'm sending this line to a Kafka queue, just the review text of part of it. Then I have my Spark application. And within that Spark application, you can see that I'm doing all the tokenization. So in this tokenized text function, I'm first tokenizing the text, then I'm removing the spaces around my tokens. I'm removing punctuation as well and weird patterns. And here I'm just doing the filtering. That's the code highlight that I showed earlier. So that for each messages that exist on the queue, we'll do all of this operation. And at the end of the day, and at the end of this process, I'm gonna append that row into a data frame. Once this is completed, uh, I'm gonna use my data frame and make some modification on it just to calculate the average number of words and the standard deviation on this. So you can see I have my Spark data frame. It's not displaying super nicely. I have only 14K rows on it. I have more than 130,000 rows in my dataset, but just for the sake of not spending a whole day training on it, I limited my dataset. You can see that my schema is perfectly kept while being in a Spark data frame, and here is the result of the average number of words and the standard deviation. In this cell now I'm moving to do the actual training on our LDA or NMF and the LSI. Then I'm displaying just the LDA because I'm really focusing on the LDA on this particular prototype. So you can see for each word I have some scoring, and then I can use this scoring to create my topic and order them by which word impact the most a given topic. Here I'm displaying the similarity, so I have two examples. The first text I have is I like this app because, and the other text I have is recommend. So here the use case would be potentially on the offline process when every day we are learning what people are telling about our app, extracting the topic, we could see if this topic are moving in one direction. And if they are moving in a negative direction, we can then make better product decision to say, well, the feedback we receive say that we are too slow, so let's improve performance. Or the feedback we receive say that the app is going too fast, so let's make the UX a bit better. And as you can see, by doing the similarities here, we can extract sentences from the feedback that we receive that correlate to the one that we entered here. Now I'm using Bokeh, the Bokeh JavaScript to display the cluster of words that we have. So we can easily and interactively zoom into our cluster of words, and we'll have to do that a couple of times just to be able to see the text. But one can see that there are some cluster of words in sense, speak, arrow. It's not necessarily obvious how they relate to each other directly, but they do. Then lastly, here I'm using LDA visualization, so we can actually do some exploration of how the different topics are distant from each other. So the first topic we have here, we have app, use, phone, like, don't, just, love, great, easy, read. Our second topic is fairly similar, but we can see towards the end that it starts diverting. If we pick another topic, we'll have something a bit more about love, great, computer, and we can just see how each word actually factoring into the topic. And so it's a very nice way to see what are the feedback that we receive, and from this feedback, what word is composing the topic. So that's it for my project. I think the next step at this point will really be for this prototype, it's just running on one VM, so it would be interesting to see how we can run on more than one VM, how it scale, measuring performance, and having more of an operation perspective on it. And then for the learnings um, that I had doing that final project was really about how quickly and conveniently we can create a prototype with a fairly big amount of data and convince ourselves that it's worth or not worth investing into a project. That's something I really like. Something else that I like was the tool NLTK and scikit-learn are fairly easy to use. There is a lot of documentation and tutorials online, so it's easy to get started with it and really have this prototype and this sense of whether we can have an answer to our question. What I didn't like is the debugging experience with Python in general, but specifically with Spark is really a bit painful, especially if we are using Lambda expression. It's become really challenging um, to debug. Right, so that's it for this video. Thank you for taking the time. Bye.